Okay, in this video we're talking about function relationships, and I'm going to go into how to find the domain and range, but also we want to be able to determine if a graph is in fact a function or not. So we're going to hit both of those topics today. So if you look, I have just kind of a working definition. It might not be the textbook definition, but this is good enough for us, especially for linear functions. And it says the relationship between a set of numbers where for each input there's only one output. Okay, and so we'll look at a few tables and then a few graphs and see what this looks like. And along the way we'll also determine the domain and the range. Okay, if you remember, domain is your input values and the range is your output values. And so that x is the input, and the x determines the domain, and the y is your output, and that determines your range. And in order for this to be a linear function, or in order to be a function, there can only be one output for each input. So let's see. The domain for this table is just going to be our values for x. So we could just write the domain is going to be, we'll try to go smallest to least or least to greatest. -1, and then I think the next one is 1, 3, 5, 7. Those are our values for our input, and then our output, or our range, is going to be 2, 3, 4, 5, and 6. And you'll notice something with me. You can't write, in this case especially, you cannot write 2 through 6, because even though we have 2, 3, 4, 5, 6, there's an infinite number of values between there. 2.5, 2.7, 2.6 repeating. So we want to, if it's a table like this, we're not going to write 2 through 6. We're going to exclude those values and just the whole numbers 2, 3, 4, 5, 6 what is written there. And so we can see that for each one input, there is only one output. Let's take a look at a few more. For this next table here, we have, our domain is going to be 2, 3, 4, 5, 6, 8. Okay, those are all of our input values. And then our output is 0, 1, 3, 4, another 1 here, and a 2. So now let's see. We want to make sure again that we only have one output for each input. So for the input of 2, we have one value of 0. For the input of 3, we have a 1, and for 6, we have a 3, and for 8, we have a 4. And now, when we come to here, we notice that if we input 4, we get a 1, but also if we input a 3, we would get a 1. Okay, so in this case, it is still a function because in order for, if we don't input a 3, and sometimes it's a 1, and sometimes we input a 3, and sometimes it's a 5. So there is still only one output corresponding to each input. So this would be still a function, and then again, you can write the domain would be these values, and the range would be those values. Okay? Now, let's look at this one. If we input a -2, we get a 4. If we input a 0, we get a 1, and 1, and 2, and then another -2, we get a 3 this time, and then -1, and we get a 5. And so you can see here that sometimes when we have the input of a 2, the output is a 4, and sometimes when we have the input of 2, the output is a 3. And so this then is not a function. Okay, we could still, I suppose, have a domain and range, but this would not be considered a function. Now, on that same note, I'm not going to go into the domain and range for these graphs that I have up here, but I want to show you another trick that you can do to find out if this is in fact a function or not. And we call this the vertical line test. And basically, if I just use this ruler as a vertical line, if I move across the graphed line on the coordinate plane, okay, there should be, at no point should the line that I graphed cross this vertical line twice. This is our y-axis, this is our x-axis, we said, or we know that. And what we're saying here is, back here was if there's a place where we have an x value and it has two or more different y values, then that's not a function. So here, if I go across, this is where the x is -4. Well, where x is -4, look, y is -1 and only -1. Where x is -3, where x is -3, y is 0 and only 0. So that's why this vertical line test, if it only passes once as you move across the x-axis, then you're only going to get one output for that value. Now here we have another graph. You'll probably do this when you go into higher level algebra. And again, even though this is a curved line, each time we do move across with the vertical line test on the x-axis, we only hit the line once. Hopefully you can see that. We're only touching it here, we're only touching it here, we're only touching this line here, the curved line. I'm only looking at the curved line. So this is also a function. Now here, if we do the vertical line test, and I haven't written numbers in here, but you can see right away that when x, let's pretend this is x is -2, well, y is like 3 or -3. So as we perform this vertical line test, if we move the vertical line across the line that we have graphed, and it touches 2 or more times, supposedly this could go like this and maybe touch 3 times, that's not a function. And last but not, let's see, we have 2 more. Here's a case where it's a curvy line, but again, as we move across the vertical line that we are using, it only touches each spot once. And here again, it looks okay until we get to about right here, and we can see here that it touches 1, 2, 3 times. So this is also not a function. When x is at this point, then y could be here, here, or down here. So hopefully that helps you get some idea of how we can determine if something is a function, and also how to determine the domain and range. Okay, as always, I thank you for watching.